Welcome to tonight's video on limits and continuity, talking about how limits tell us if a function is continuous or not at a certain point. If you look at these graphs here, like this one, notice at point A. Then if we look at the next one, at point A for x, and then we look at the third one at point A for x. Notice each one of the three, notice if we were to draw the function, we would have to stop, pick up our pencil, and then continue on. So the fact that you can't just make one continuous line without picking up your pencil, that means the function is not continuous. All right, so if it's continuous, it can be drawn without picking up your pencil. That's what it means to be continuous. So algebraically, to find out if a function is continuous at a certain number, there's three conditions. Number one, the function is defined at that x-coordinate a, that is, a is in the domain of f, so that f of a is a real number. Number two, the limit as x approaches a of the function exists. And number three, the limit of the function as f approaches a is equal to f of a. If it is not continuous at a, we say that f is discontinuous at a. So to examine whether the function is continuous at certain numbers, like for example, this function is continuous at 2, the first thing that we do is find what f of 2 is. So that's equal to 2 times 2 plus 1, and then 2 times 2 squared minus 2 minus 1. So that gives us 5 over 5, because you have 4 times 2 is 8, minus 2 is 6, minus 1 is 5, which is 1. So f is defined at 2. So that's one part. Then the limit as x approaches 2 of the function is equal to, since it's a quotient, it's going to be the limit as x approaches 2 of the numerator, which is 2x plus 1, over the limit as x approaches 2 of the denominator, which is 2x squared minus x minus 1. So we get 2 times 2 plus 1 over 2 times 2 squared minus 2 minus 1. So it's 5 over 5, which is 1. So the limit as x approaches 2 of the function is equal to 1. So the limit as x approaches 2 of the function exists. Since the limit as x approaches 2 of the function is equal to f of 2, the function is continuous at x equals 2. There is no hole or anything that makes it discontinuous. So if we look at b, if we find f of 1, so that gives us 2 times 1 plus 1 over 2 times 1 squared minus 2 minus 1. So notice it gives us 3 over 2 minus 1. or sorry, it should be 2 minus 1 minus 1. That should be a 1. Sorry about that. So then it's 0, which means it's undefined, which means f is not defined at 1, which means f is discontinuous at x equals 1, meaning that there's not a point there. It would either be a hole or an asymptote or something like that. So that's how you show if it's continuous at a certain point. It has to meet all three of those criteria. If it doesn't meet one of them, then it's not continuous. So let's look at the next example. This function, so now at 2, so let's try f of 2. So 2 minus 2 over 2 squared minus 4. So you get 0 over 0, which is undefined, which means f of 2 is not defined, or f is not defined at 2. That's a better way to say it. Which means the function is discontinuous at x equals 2. So if we go for the next one, if we look at the next one, f of, this was part A. We look at part B, f of 1 is equal to 1 minus 2 over 1 squared minus 4. So it's negative 1 over negative 3, which is 1/3. So f is defined at x equals 1. Now we have to determine what the limit is as x approaches 1 of the function is going to be the same as the limit as x approaches 1 of x minus 2 over the limit as x approaches 1 of x squared minus 4. So 1 minus 2 over 1 squared minus 4. Negative 1 over negative 3 is 1/3. So the limit as x approaches 1 of the function exists. Not only does it exist, but notice it's the same as f of 1. So since the limit as x approaches 1 of the function is equal to f of 1, then f is continuous at x equals 1. So it's not continuous at 2, but it is continuous at 1. All right, so we'll do the same thing with piecewise functions to determine if they're continuous or not. There's actually two things, that we have to do. Number one, check whether each of the three pieces of the function are continuous. So if you look at the three pieces, you have a line, right? X plus 2 is a line. 2 is a horizontal line. And x squared plus 2 is a parabola. All three of those functions are continuous. They do not have any restrictions on the domain. So therefore, these three functions are continuous on their own. So now, looking at the piecewise function, we have to determine to see where the conditions change if they are continuous. So there's two places they change, at 0 and 1. So we're going to check if it's continuous at 0 first. So f of 0 is equal to 0 plus 2, which is 2, because that you put it in the top there. So f of 0 exists. Now let's try to find the limit as x approaches 0. Now in a piece function, we do have to find the limit from the left and the right. So the limit from the left of the function, that's when it's less than, so 0 plus 2 is equal to 2. The limit from the right of the function, well, from the right is between 0 and 1, so it's equal to 2. So that means the limit as x approaches 0 of the function is 2, since from the left and right it's 2. That means since the limit of the function as x approaches 2 is equal to f, or sorry, not of 2, of 0, is equal to f of 0, that means f is continuous at 0. So now we see if it's continuous at 1, because 1 is the other place where it changes. So f of 1 is equal to 2. And then we say the limit as x approaches 1 from the left of the function, well, that means we're going to put it in here, and that's equal to 2. The limit as x approaches 1 from the right, that's when it's greater than 1, so that's equal to 1 squared plus 2, which is 3. So the limit as x approaches 1 of the function does not exist, since the right and left hand limits are not the same. Therefore, f is discontinuous at x equals 1. So that is the one place where it is discontinuous. So let's try the next one. So notice all of these functions, you have two linear functions and a parabola, so they are continuous on their own. So now we're going to check the boundaries. So at 0, f of 0 is equal to 2 times 0, which is 0. The limit as x approaches 0 from the left of the function is equal to, well, less than 0 is 2 times 0, which is 0. The limit as x approaches 0 from the right of the function, well, from the right is when it's bigger than 0, but it's going to be this one, so it's 0 squared plus 1, which is 1. So the limit as x approaches 0 in general does not exist. So since the limit does not exist, that means f is discontinuous at x equals 0. Now the only thing we have left to determine is it continuous at 2, the other boundary point. So let's check. F of 2 is 2 squared plus 1, which is 5. The limit as x approaches 2 from the left of the function is 2 squared plus 1, which is 5. The limit as x approaches 2 from the right of the function is when it's greater than, so 7 minus 2 is also 5, which means the limit as x approaches 2 of the function, since the left and right limit are both 5, is 5. And since, notice f of 2 and the limit are the same, since the limit as x approaches 2 of the function is equal to f of 2, f is continuous at 2. So that means the only place it's discontinuous is at x equals 0, and that's what it's asking. All right, so that's our video for this evening. I hope you have a good Friday and a good weekend, and be nice to your mothers for Mother's Day. And I will see you next class. Have a good evening.